Hello and welcome back to our podcast. And we having these holidays coming in front of us, and we have a great research that came out recently in eLife Journal, and we have invited Professor Ancha Baranova to give an overview what she has found in this paper that is really important before people will jump into planes and have nice holidays somewhere in a hot country. So, hello, Ancha.
Hello, Valentina. Very glad to talk to you.
So, give us a little bit of an overview about this nice paper that you came across that is really relevant now in these times when we got nice sunny days and people plan their holiday trips and usually will be taking flights. So I will pass it on to you. So please take this time.
Thank you so much, Valentina. Well, paper is real good, but the message coming from this paper is not super great, I should say. So let's see what has been done. First of all, the paper is from United Kingdom. And United Kingdom is the great country in the world for many things, including for very tight surveillance of coronavirus. So thank you so much, Englishmen, for publishing all the data on sequenced coronaviruses, all the variants, etc. The study which has been done on people who were flying to England from other places, so there were international flights, and the study subjects were just airline passengers. And remember, in order to enter the flight, those people should be having negative PCR test. If they had no negative PCR test, so if they were positive, they wouldn't be on the plane, right? So everybody who entered the plane was negative on the moment when they boarded the plane. Then what was done by scientists in the study is that as soon as the plane landed, they did 2 tests for coronavirus for those passengers, but instead of stopping at the so-called cycle 30, that is a real-time PCR-based detection of the coronavirus, which has certain cutoff, because as soon as you are going to the lower cutoffs, you are able to increase sensitivity and you catch more cases, but there will be an increase in the false positive results, because we don't want to alarm people falsely and say, oh, you might have coronavirus, and they really don't. We have to stop early and detect infection with larger number of virus particles, not just some random virus caught in the middle of the flight and dead right there on the surface of the nose, or something like this. Remember, everybody who entered the plane was negative, but then the company which was profiling the swabs from the passengers on arrival, this company made the PCR not to the cycle 30, but to the cycle 39 approximately. So they did low-level detection. If you have just a little bit of virus, it will be detected with this technique. But in order to exclude false positive, what those people did, they sent all the samples to sequencing. Because if you're able to sequence the virus from those samples, that means for sure it's not a false positive, it's a real virus, right? Surprise, surprise, 1.9%, that means 1 out of 50 passengers who were negative when they boarded the plane, they were positive on this test when they came out of the plane. That means that substantial amount of infections were missed by PCR. And that means that when you're flying on the plane, there is a possibility that somewhere around 50 people around you, somebody is positive. And this possibility is very large because 1 out of 50 turned to be positive, right? Now, of course, there is ventilation in the plane. And of course, people are wearing masks. But possibility of actually catching the virus during the flight dependent on how long the flight is, right? And how close you are sitting to the person who is breathing out the virus. And when person is breathing out the virus, for example, taking out mask when need to eat or something like this, that is repetitive breathing within the small space, right? So depending on how exactly the air conditioning was located above your head, you have higher or lower possibility of actually contracting the virus. But it's not the only conclusion done from this paper. This paper has much more data, very, very important for everybody. So the paper was actually done before the Delta variant became absolutely predominant in the United States. So it was like a little bit earlier than that. So they actually surveilled all the variants which were coming in UK in those arrivals. And there was equal mix. So there were alpha variant, British variant coming back. There was beta, there was gamma from South America, there was delta, of course. So they can at that time compare the viral loads for delta and for other variants. Because when you do PCR, the number of the cycle at which your PCR become positive is proportional to how large viral load you have. So what they showed, that people who carried delta on average had 21 times more virus than other variants. I should say that the number 21 is a large number, but it shouldn't really scare you, because for world of viruses, we are operating orders of magnitude. It is not uncommon to have 100 times differences, and even 500 times differences between like super spreader and the person who's just having regular amount of virus. But you see that delta is looking closer to be a super spreader virus than the standard virus. That's another conclusion which we should make from this paper. And last but not least, what was really interesting is that on arrival, they also collected from all those people their vaccination status. They have not collected any personal data except vaccination status, like one vaccine or two vaccines, right? They were not distinguishing between one and another type of vaccine. So we don't know who got AstraZeneca, who got Pfizer, right? But they only knew vaccine yes twice, and they also knew age of the person. But that was enough of the data to do very important conclusions. So the least protected group, which was not sick, but able to carry coronavirus and spread it, therefore, there were people over 60 who get one shot of vaccine. So one shot and being over 60 protects you against carrying coronavirus for only 5%. You remember? We are talking 80%, 90% of protection for the vaccine. This is 5% of protection. So for older people over 60, it's not that old, only 5% protection from one shot. So this group of people for sure need to get two shots, right? Predictably, the most protected group was the group who was younger than 60 and get two shots, right? Two other groups, meaning more than 60 and two shots, less than 60 and one shot, they were in the middle of this, which means that we really, majority of us need two shots. And even for the younger people with two shots, the protection against carrying coronavirus, not being sick, but carrying coronavirus on the plane was 80-something%, like 83 or something like this. So it was not absolute. We were not able to guarantee that person will never carry coronavirus in the throat and in the nose cavity. So if you are planning to travel, please, in addition to general precautions which you are having on the plane, you need to look at additional measures for yourself. First of all, wear respirator like N95 respirator, not a mask. Yes, you can wear a mask. By majority of the airplane rules, you can wear a mask, but it protects you to much lesser degree. It's much better to have a respirator. Second, you need to really honestly wear this respirator, because I saw those people who put a finger on the respirator because it's easier to breathe this way, right? But it kind of defeats the purpose, right?
Below the nose.
Yeah, below the nose, right? And yeah, we saw those pictures on the internet, like people put them on the ear, put them under the chin, etc. But even such a little thing as just putting a finger there, that's not a good idea on the plane, really. Especially if you are older, and especially if you get only one vaccine shot. because in this case, Delta on the plane can get to you. And yes, this one vaccine shot will protect you to a certain degree, which means that you will not get to the hospital, or you will get to the hospital, will be treated, and you will never get into the intensive therapy. But still, it's not a good thing because the coronavirus is having long-lasting impact on people, and I wish everybody to escape this impact rather than try to adjust.
Thank you, Ancha. I think it's really good hints to people when they plan their holidays. And again, when we have this Delta variant now dominant in the UK and now in the European countries as well, think twice before you plan to go anywhere. Thank you, Ancha, for this overview, and we'll speak to you later then, and see you next time.